Example number 5, compute the limit of square root of x squared plus 1 minus x as x approaches to infinity. If we just do the limit of 1 by 1, because we see the minus in the between, then we will have in the head is this will give us infinity minus infinity. So after we did example 2, 3, 4, 5, up to this example, let's write down the note for this, okay? So when we want to find the limit as x approaches to infinity, and then you plug infinity into the function, then you will have the case where infinity divide infinity, or the case that infinity minus infinity, like example number 5, or even plus, okay? On the infinity divided by infinity, you see that in example number 4 above, example number 3 above. Then we need to manipulate our function. We use some algebra to do that. So we cannot have infinity divide infinity, or infinity minus or plus an infinity. So now let's fix our problem. So x approach to infinity, so I'm gonna use the a minus b, the special product, a plus b equal to a squared minus b squared. So I need to have the conjugate. So we call that is the conjugate. So I already have minus. So what do I need to do is I'm gonna multiply by 1, and that will give me square root of x squared plus 1 plus x. So I'm gonna do that for top and bottom. So what do we have on the top is that we use a squared minus b squared, so we get x squared plus 1 minus x squared. And in the bottom we have square root of x squared plus 1 plus x. So we can cancel out the x, so we get this, right? Now we can plug in the infinity, and we see that on the top is 1, in the bottom is really large number, and when we have 1 divided by really large number, we will have the answer is 0. And notice this step you should not write in the show work, but you should write outside, but you just directly do from this to this and write down the answer is 0. Example number 6, in this problem is a little tricky. We need to do the substitution for this problem. So we're gonna let t equal to 1 over x minus 2. And we see that when x approaches to 2 on the right side, this number is bigger than 2, right? So minus 2, so you're gonna have approach to 0 for that, but it's positive 0. So 1 divided by positive 0 will give you a positive infinity. So we can say that it's the same thing as it's implied that t approach to positive infinity. So now this equal to the limit as t go to infinity of the tangent inverse or arctan of t. And when t go to infinity, the tangent inverse, so let's recall the tangent inverse, the graph of the tangent inverse is like this. So we have pi over 2 and negative pi over 2. So you have t or x, doesn't matter, right? So when we go far away, when t go to infinity, the function will go to pi over 2, because the functions will be like this. Okay, so we look at this point and you see that is approach to pi over 2, and negative pi over 2 when t go to negative infinity. So in this case, we have positive pi over 2.